Techniques under comprehensive reasoning and verification. Under this category, we'll explore several innovative techniques: automatic prompt engineer, APE, self-consistency, ReAct framework. Automatic prompt engineer, APE, is a technique that optimizes instructions by treating them as programmable elements. It searches through a pool of instruction candidates, generated by a language model, LLM, to find the most effective prompt. Inspiration draws from classical program synthesis and human prompt engineering, utilizes principles from program synthesis to automate prompt generation. How does APE work? 1. Candidate generation. The LLM generates a diverse set of instruction candidates for a given task. 2. Scoring function. Each candidate instruction is evaluated using a scoring function that measures its effectiveness in eliciting the desired response from the LLM. 3. Selection. The instruction with the highest score is selected as the prompt for the LLM. Benefits of APE: efficiency, automates the prompt generation process, reducing manual effort. Performance enhancement, improves the effectiveness of prompts by leveraging the LLM's own knowledge. Adaptability, can be applied to various tasks and domains. What is self-consistency? Self-consistency is an advanced prompt engineering technique designed to enhance the reliability of chain of thought, COT, prompting. It addresses limitations of basic greedy, decoding by sampling multiple reasoning paths and evaluating them for consistency. How does self-consistency work? 1. Multiple reasoning paths. Using few-shot COT prompting, the model generates various reasoning chains for the same question. 2. Sampling diverse paths, encourages diversity in reasoning to explore different approaches. 3. Evaluating responses. The model assesses the generated answers to identify the most consistent and accurate one. Benefits of self-consistency: improved accuracy. By considering multiple reasoning paths, the model reduces the chance of errors. Robustness enhances the model's ability to handle tasks requiring arithmetic and common-sense reasoning. How does ReAct work? Dynamic reasoning and acting combines internal reasoning with external actions, allowing models to adapt dynamically to complex tasks. Interaction with external sources. Models can interact with external environments, such as knowledge bases or search engines, to retrieve additional information. Iterative process. The model generates reasoning steps, performs actions based on those steps, and updates its reasoning with new information. Benefits of ReAct: improved performance, enhances task performance by allowing the model to access and utilize external information. Better interpretability, makes the model's decision-making process more transparent and understandable. Reduced hallucinations, by grounding reasoning in external data, it minimizes the risk of generating incorrect or nonsensical information. Example: prompt, model's response, reasoning. The largest country by land area in South America is Brazil. Action, lookup, search for the capital of Brazil. External tool response, the capital of Brazil is Brasilia. Conclusion, answer, the capital of the country with the largest land area in South America is Brasilia. To sum up, comprehensive reasoning and verification techniques enhance the model's capabilities by encouraging detailed reasoning and self-checking, integrating actions with reasoning for dynamic task handling, reducing errors and improving the reliability of outputs. Transitioning to our final main category, let's explore how models utilize external tools and knowledge. Usage of external tools/knowledge or aggregation. This category includes techniques that leverage external sources, tools, or aggregated information to improve language model performance. The emphasis is on accessing additional knowledge or tools to provide more informed and contextually rich responses. Key aspects: external knowledge integration, incorporating information from outside the model's training data. Tool usage, utilizing calculators, search engines, or APIs. Aggregation, combining multiple responses or reasoning paths to enhance robustness.